Okay, so we're going to go through a whole bunch of different examples today. Okay. First thing, here are just kind of some general rules that you probably assumed anyway, okay? If you have the sum inside of an integral, then you can break it up into two separate integrals, okay? You probably did that in your head anyway, right? If you have, same thing, the difference inside of an integral, you can separate it into two integrals. If you have a constant inside the integral, you can move the constant outside the integral to take the antiderivative and still multiply by the constant at the end. Okay? All of these rules, like I said, you probably assumed in your head anyway, but now we have made them understood. Okay, let's talk about the rules that we went over yesterday. Okay? If we take the antiderivative of 0, we get c, constant. If we take the antiderivative of k, we get kx plus some constant. If we take the antiderivative of x to the n, we increase the power and divide by that power or multiply by the reciprocal of that power. And of course, we need to add c. Okay? Now, what we are going to look at today are some more complicated examples. All right? I have this down here. Rewrite before integrating or before taking the antiderivative if necessary. Okay, right now we only have these 3 rules. Okay? And our list of rules is not going to get very much longer. Okay, so if we can rewrite it to use the power rule, we need to do that to make our lives easier. Okay? So, like this one. There is no quotient rule for antidifferentiation. All right? However, we can rewrite this to use the power rule 4 different times. Okay? How would we rewrite this? Right. What is x cubed over x squared? X. Minus 5x squared over x squared. Plus x to the 1/2 divided by x squared.
X to the 1 negative 3. X to the 3
Oh, we are having some
X to the
issues.
negative 3
X to the negative 3/2. And then 7 over x squared we're going to write as
7
we're going to write it as 7x to the negative second. So now we have x to a power or constant for each one of our terms. Okay? So what's the antiderivative of x?
X squared. 1/2 x.
Increase the power, divide by the power, right? Negative 5 becomes?
Negative 5x.
Negative 5x. If it's a constant, tack on an x to it. All right. Power rule. We are going to increase the power, so that makes x to the negative 1/2, and then we're going to divide by negative 1/2. Okay. And then minus 7 times x to the negative second. It becomes x to the what?
1. Negative 1.
Negative 1, and we divide by negative 1.
Plus c.
Very good. Plus c. Okay, so this is the same as x squared over 2 minus 5x minus 2 over the square root of x plus 7 over x plus c. Okay, you can write it either way. Find it? Okay. Here we go. How about the integral of the square root of 5x plus 2? Do we have a chain rule for antidifferentiation? Okay, I haven't told you about one. We really don't. But we can think about applying the chain rule from our antiderivative back. All right? So first of all, let's write this as 5x plus 2 to the 1/2. Right? Now, if we were to take the power rule on this, what would we do?
Of the entire quantity.
Well, we would take our power and do what with it?
Increase it by 1.
Increase it by 1, and then we would divide by that or multiply by the reciprocal of that power. Now, if we take the derivative of this, are we going to get back to the square root of 5x? Why?
Because you take the derivative of that, you have the 5.
Okay, if we take the derivative of this, if we did the power rule, this would come down and cancel out, and it would be 5x plus 2 to the 1/2. But then we would have to multiply by 5 because it's the derivative of the inside, correct?
So you need
Is everyone listening, or do I need to write that over here?
So you need to
Okay.
divide it all by 5.
So we would need a divide by 5, or 1/5. Okay, over here, if I had the 2/3 5x plus 2 to the 3/2, if we took this derivative, our power would come in front and cancel out. We would have 5x plus 2 to the 1/2, and then we would multiply by the derivative of the inside, which is 5. Okay, so to account for that, we're going to multiply by 1/5 when we're going to the antiderivative working backwards. Okay, so this becomes 2 over 15, 5x plus 2 to the 3/2 plus c. Okay, you saw a little bit of that yesterday, correct? When you had the sine of 5x or the cosine of pi x or whatever we had, right? Okay, same kind of thing, right? Let's talk about some trig functions. Okay? You need to know these rules. Okay? Whatever's in red, you need to write down. Okay? All right. If we have the sine of x, the derivative is cosine of x. So what would the antiderivative of cosine of x be? Sine of x plus c. Okay. If we have cosine of x as our function, the derivative is negative sine of x. So what's the antiderivative of the sine of x? Ooh, very good. Negative cosine of x plus c. Please notice how your negatives are now with the opposite function when we're going the opposite direction. Okay? That's going to be the hardest part, is remembering where the negative goes. Okay? Let's continue. The derivative of the tangent is secant squared. So, if I ask for the antiderivative of secant squared, we are going to get okay. What do you think is going to be next? We do secant. The derivative of secant is secant tangent. So, if we're taking the antiderivative of secant tangent, we're going to get secant of x plus c. What's the derivative of cosecant? Negative cosecant cotangent. All right. So if we're taking the antiderivative of cosecant cotangent, we're going to get negative cosecant. So that's plus c.
Why do you have to have the dx there?
That's telling you what you're integrating with respect to.
Can you integrate it with respect to y?
Yes, and then that would just mean everything that had an x would be used as a constant. Derivative of cotangent is negative cosecant squared. So the antiderivative of cosecant squared is where are the negatives?
With the c's.
With all the c's. Okay. If I gave you a piece of paper that had all the derivatives and all the antiderivatives, you should be able to just do them all. Power rule, trigonometric functions, all of them. Okay, these should be, by the end of this week, these should be automatic to you. Okay, for today, we're still learning them. All right, so I want the antiderivative of the cosine of 7x. So first of all, what's the antiderivative of cosine? Sine. So we're going to have the sine. The angle's going to stay the same. Now we're going to have to multiply by 1/7 to make up for the chain rule if we would have to go backwards. Right? Plus c. Is everyone okay with that 1/7 difference?
Yes. If it were 7 squared plus x.
Ooh, that is when we get complicated, and that'll be more for tomorrow. Okay, when there's more than a linear function inside of a function, we have to have a special technique that we will learn tomorrow and Thursday and Friday.
It sounds lovely.
It is. All right, how about this? Ooh, there's a different variable. Okay. Now this says d theta, so we're integrating with respect to theta. Nothing changes. What's the antiderivative of theta? Increase the power, divide by the power. Right? Negative sine of theta would go to a positive cosine of theta, because the antiderivative of sine is negative cosine. Okay. Antiderivative of secant squared? Tangent of theta. Okay, and then don't forget your plus a constant. Feeling okay? How about now?
It's all pixelated. I can't do this.
Okay. We could separate it, and we could follow my hint from the very beginning. Okay, rewrite it. Now in this case, we would rewrite it so we could use our trig rules, right? Power rule is probably not going to help us out much here. So cosine cubed over cosine squared.
Cosine. Yeah, that one was nice.
Sine over cosine squared. Okay.
We can multiply cosine.
Well, let's do this. let's group sine with one of the cosines. And then we would have a cosine left over, correct? Okay, so we have the cosine of b plus sine over cosine would be tangent. And 1 over cosine? Secant. Now, is it okay that I wrote them in this order?
Yes.
Okay, I just switched orders so it read secant tangent because we're more familiar with that order. Multiplication's commutative, so this is sine, right? So now what's the antiderivative of cosine?
Sine of the
And what's the antiderivative of secant tangent?
secant of the plus c
Plus mu.
Okay, so you may have to use some identities to help you. What is sine squared plus cosine squared? 1. Okay, you may need that. I don't remember.
What was the other one? Was the other one?
There's like 6.
There's Pythagorean identities.
Yeah.
Okay, let's review those real fast. Sine squared plus cosine squared equals 1. If I divide everything by sine squared, we get 1 plus cosine over sine is cotangent, and 1 over sine is cosecant. If I divide this first one all by cosine squared, we get tangent squared plus 1 equals secant squared.
No one ever explained it that way. They're just like, okay, here's these identities, but that makes so much more sense.
Okay, so there are those. They're in your book too. And probably on that piece of paper I gave it to
I
you.
always got the first one, and then the other one.
That makes so much sense.
Okay. All right. Are you ready for the easiest rule?
Yes.
It should not be easier than simple addition.
What was the easiest thing to derive
Power rule.
0.
Constants.
0.
Nothing.
besides those? The function. What's the easiest function besides linear? Besides linear.
Not a function. We derive nothing.
E to the x.
What's the derivative of e to the x?
E to the x.
E to the x. What's the antiderivative of e to the x?
E to the x.
Plus c.
Plus
Okay,
c.
it can't get any easier than that, right?
Other than the derivative of a constant.
Or 0.
That one's pretty easy.
Okay,
What's the antiderivative? Aaron, what's the antiderivative of 0?
C.
All real numbers.
let's apply it.
B, right, it was C.
The antiderivative of e to the negative 2x. Just like with differentiation, okay? E to the x, when you derive it, it stayed the same, maybe with the chain rule thrown in, okay? So here, the antiderivative of e to the negative 2x is still going to be e to the negative 2x, but since I have that negative 2 in front of my x,
Oh, negative 1/2.
we're going to have to multiply it by negative 1/2 to make up for the chain rule drawing backwards.
Plus c.
Plus c.
Okay.
Write it all by E.
We have to
Okay,
separate.
we need to rewrite this. I would rewrite this as 5 times e to the negative 2x minus, this becomes e to the,
negative 1.
right, because x minus 2x would be negative x, and subtract our powers dividing. Okay, so now when we integrate, okay, e to the negative 2x e to the negative 2x. We still have our 5 out in front. And then since we have a negative 2 there, we're going to have to multiply by
Negative 1/2.
negative 1/2 to make up for the chain rule. All right? And then here, when we take negative e to the negative x, we take the antiderivative, and it becomes what?
E plus e to the negative x.
Plus e to the negative x. Okay? Because when we take the antiderivative, we still have e to the negative x. We have to make up for that negative sign with the chain rule until we switch the sign. Okay? Now remember yesterday I said you should get everything right because we can check our work. Is the derivative of negative 5/2 x to the negative 2x the same as what we have up here?
Yes.
Is the derivative of positive e to the negative x that? The derivative of c?
Is 0.
0. Okay?
That's
You
not
should
fair.
always be able to check your work. Okay? Now, if you mess up rewriting, you know, there's not a lot I can do there to catch your mistake as far as just going back to look at it. But when you take the derivative of your answer, you should get back to where you started. Smart board is driving me nuts. Okay. Will our power rule be sufficient for the integral of 1 over x?
Yeah.
Okay, so I rewrite it to what? X to the negative 1. And we say, okay, increase our power
0.
and divide by...
Oh, snap.
Not going to work, is it?
Yeah, no.
Shoot.
What is it?
I'm fine. We have a problem where we're just trying to guess nonsense.
What could we take the derivative of to get 1 over x?
Nothing.
There's a function.
Negative.
No. What, Kelly?
It's some
X times.
I know.
X times 1 over x.
Is it? It starts with d over dx first.
Like the bracket.
No.
Would you have a bracket, maybe, to start it off?
And then 1.
Minus x.
That's not a 1.
That's a. What
Gross.
The natural log. If you take the derivative of the natural log, it's 1 over x, right? Yeah. We should know that.
Those L's look like 1s.
Which means
I think they are.
the antiderivative of 1 over x should be the natural log of x. Now, I am going to do something here, though. Why am I putting an absolute value there?
Because it can't be negative.
Okay, we can't have negatives inside of our natural logarithm. All right, is it possible, is it okay for negatives to be here?
Yeah.
Yes, but not when we take the antiderivative. So you need the absolute value when you take the, when the natural log is your answer for antiderivative.
I think those L's and the 1s are the same.
All right, let's do some examples. Okay, if it helps you, you can rewrite this as 7 times the integral of 1 over x dx. If it helps you.
It does.
Which means this is 7 times, what's the integral of 1 over x?
Natural log of x plus c.
Yeah.
Right? Okay. Simple. How about this one? Okay, can I rewrite this?
No.
You cannot break apart a denominator.
Oh, darn it.
Okay, but I still have 1 over something, don't I? Yeah, and that something is linear, so that's good. So this is just going to be what?
Natural log of the absolute value of x minus 5. Plus
The natural log of that denominator. Okay? As long as this is linear, we can just go straight to there.
Is it impossible to break down a denominator, or is it just super long and horrible?
In this case, it's linear. We can't break it down any further.
Then that's what I'm gonna prove. When I'm older, that's gonna be my one.
Well, I mean, technically, you could probably. Well, how about this? You can't break it up anymore polynomially. So, yeah, you could break this up into the square root of x minus the square root of 5 times the square root of x plus the square root of 5, but that's not
Well,
going to
see,
be
there you
easy.
go. Let's split it up.
And then you could do partial fractions.
Yeah.
Yeah, that's going to get you in a worse place.
That's what you did.
Here, do this.
All right, how about this?
It's still linear. It's still just the same thing.
Okay, you have 1 over something linear.
Yeah.
So we're going to have the natural log of
Everybody
outside
needs
3x plus 2.
Then you need to have something else, don't you?
1/3.
We're going to have to multiply this by 1/3 so that if we take the derivative of our answer, we'll get back to here. We have to make up for that chain rule. Plus example.
Oh, no.
Yeah, we can just divide
Break
it
it
out.
up.
Okay, sorry, I have to take a break. My son is 1.5, and he says, "Oh no," all the time. But and like there's a song where we sing, "Oh no," and we put our hands right here. But he does this. And, oh no.
You're doing the signal evil.
It's the cutest thing ever. But it's just funny because we do this, but he thinks it's over his ears, so he does this. So we watch Thomas the Tank Engine. Anybody?
Oh, yeah.
Okay.
You know,
So
there's a balloon in the Macy's Day Parade for Thomas.
You know that there used to be.
So if something happens
place
on
out
Thomas,
the
he'll
grass
go,
where you go to and make
"Oh
out Thomas.
no." It'll cover his ears. That's really funny. Okay. Sidetrack. All right. We need to rewrite this. How can we rewrite this?
1 over x.
This becomes 1 over x. Plus, this becomes
2x to the negative 2.
Oh, thank you for thinking ahead there. 2x to the negative 2. We can rewrite that one as a nice power rule for us, right? So the antiderivative of 1 over x,
Natural log of x.
natural log of the absolute value of x,
Plus
all right, plus 2 times x to the
negative 3.
-1.
negative 1 divided by negative 1.
Plus.
I like that one.
Okay. Now, the hardest part is probably going to be, you're going to need to recognize when you need to rewrite and how you need to rewrite. After you have it rewritten, our rules are simple. Okay? So those are going to be the trickiest problems, is when you have to rewrite something. Okay? Otherwise, we have the power rule, obviously a constant. We have e to the x, we have natural log of x. And you have your 6 trig rules. Okay? So, I have kind of a hodgepodge of assignments for you. The first thing I want you to do is page, I don't know.
Page IDK.
Page
Let me figure that out.
Find the page and just do this.
And I have another joke worksheet for you.
Oh, dude, it seems like a joke. No, I'm excited.
I'm still excited. Those are fun.
More work, man.